to our comprehensive English language lecture series designed to help you prepare for the German driver's license theory test. We understand that it can be quite challenging to find and attend English language classes in traditional driving schools in Germany, and that's why we've created this resource for you. In these 14 lectures, we'll cover all the essential topics you need to master in order to pass the theory test with confidence. We'll break down the complexities of German road rules and regulations, making them easy to understand and apply. So, whether you're a newcomer to Germany or simply prefer to study in English, you're in the right place. Don't miss out on this valuable opportunity to gain the knowledge you need to succeed. Subscribe our channel now and take the first step towards achieving your goal of obtaining a German driver's license. Let's get started.
In the context of obtaining a driving license, it's crucial to recognize that driving at an appropriate speed is a leading cause of accidents. These accidents tend to occur more frequently in specific areas, such as intersections, curves, and pedestrian crossings, which are considered accident-prone zones. However, it's worth noting that driving too slowly can also be hazardous, as it can disrupt traffic flow and lead to rear-end collisions or risky overtaking maneuvers. This information underscores the importance of finding a balance between speed and safety when navigating various road conditions, as this is a key aspect of preparing for the driving license theory test. There could be questions in the test to ask where accidents occur more frequently. One critical aspect to consider when preparing for the driving license theory test is the profound impact of speed on fuel consumption and emissions. Driving at higher speeds significantly increases both air resistance and noise, contributing to higher fuel consumption and greater emissions. On the contrary, adopting a smooth and anticipatory driving style can effectively reduce fuel consumption and minimize environmental impacts. This underscores the importance of not only adhering to speed limits, but also adopting eco-friendly driving practices when operating a vehicle. Reaction distance is essentially the space a vehicle travels from the moment the driver perceives a potential hazard on the road to when they initiate the braking process. Understanding this distance is crucial because it directly affects a driver's ability to respond to unexpected situations effectively. In essence, it emphasizes the importance of maintaining focus and alertness while driving to reduce reaction time and enhance overall road safety. In recent years, modern passenger cars have witnessed a significant surge in performance capabilities. This has led to the effortless attainment of speeds while surpassing the recommended highway guideline of 130 km per hour. The combination of smooth handling and enhanced directional control can sometimes lead to an underestimation of your actual speed. You can easily calculate the reaction distance by kilometers per hour divided by 10 and multiplied by 3. The outcome of the formula will be the distance covered in meters per second. So if you drive 100 kilometers per hour, the car covers a distance of 30 meters per second. If you drive 50 kilometers per hour, the car covers a distance of 15 meters per second. Braking distance refers to the distance a vehicle travels from the moment the driver applies the brakes to the point where the vehicle comes to a complete stop. It's important to note that braking distance is influenced by several critical factors, including the grip of the vehicle's tires on the road, the effectiveness of the braking system, and the driver's behavior. Understanding the factors that affect braking distance is essential for safe driving. Drivers need to be aware that road conditions, such as wet or icy surfaces, can significantly increase braking distance, requiring them to adjust their driving behavior accordingly. Additionally, maintaining a safe following distance from the vehicle in front is crucial to allow sufficient time for braking and prevent rear-end collisions. It's important to note that a vehicle's ability to slow down isn't solely determined by tire grip and braking system efficiency. A significant factor is the driver's skill. This is why we differentiate between normal braking and emergency braking scenarios. Braking distance is the distance from the start of braking to where your car comes to a stop, and it is calculated by dividing kilometers per hour, or V divided by 10 and multiplied by the same. Kilometer per hour, or V divided by 10. V is the speed in kilometers per hour. Example, at 50 kilometers per hour, bring your car to a stop by normal braking. So you calculate 50 kilometers h divided by 10. Take this value and multiply it by the same value. Consequently, your car stops after 25 meters. Stopping distance encompasses both the reaction distance and the braking distance. The reaction distance is the distance a vehicle travels from the moment the driver recognizes a hazard and decides to apply the brakes until they actually start braking. This reaction time can vary from one driver to another and is influenced by factors like attentiveness and alertness. The braking distance, as discussed earlier, is the distance the vehicle travels from the start of braking until it comes to a complete stop. It is influenced by factors such as tire grip, the condition of the road, and the efficiency of the vehicle's braking system. It's crucial to emphasize that real-world factors, including road conditions, weather, and the driver's state of mind, can all impact stopping distance. Understanding and accounting for these factors are vital for safe and responsible driving. So, when we add the reaction distance to the braking distance, we get the total stopping distance. In essence, it accounts for the distance it takes for you to react to a situation and then apply the brakes, as well as the distance your vehicle travels while it's actually coming to a stop. This concept is crucial for understanding how quickly your vehicle can come to a halt in response to different situations on the road. Let's say you're driving your car at a speed of 60 kilometers per hour on a clear, dry road. Suddenly, you see an obstacle in the road ahead that requires you to stop. For example, reaction distance, the average reaction time for a driver is about 1 second. During this time, your car continues to travel at the same speed. At 60 kilometers h, in 1 second, you would cover a distance of approximately 18 meters. Braking distance. Now, you've applied the brakes to stop your car. Assuming your car has good brakes and tires, and the road conditions are favorable, your car may require an additional distance to come to a complete stop. Let's say, in this scenario, the braking distance is 36 meters. Total stopping distance. When you add the reaction distance to the braking distance, you get the total stopping distance. In this case, it would be approximately 54 meters. So, if you were driving at 60 kilometers h and needed to stop suddenly, your car would travel about 54 meters before it comes to a complete stop. This illustrates how important it is to consider both your reaction time and braking distance when thinking about how quickly your vehicle can stop in response to a situation on the road. Normal braking refers to the standard process of slowing down or coming to a stop when driving a vehicle. It's the controlled application of the brakes to reduce speed or halt the vehicle in a predictable and gradual manner. In normal braking, the driver applies steady and moderate pressure to the brake pedal. This type of braking is typically used in routine driving situations, such as slowing down at a traffic light or stop sign, or gently slowing down on the highway when approaching an exit. Normal braking allows the vehicle to decelerate in a stable and predictable manner, ensuring the safety of both the driver and other road users. The braking distance in normal braking is determined by factors like the vehicle's speed, road conditions, conditions, and the condition of the brakes and tires. Emergency braking, on the other hand, is an abrupt and forceful application of the brakes, often used in critical or unexpected situations to stop the vehicle as quickly as possible. In emergency braking, the driver applies maximum force to the brake pedal in a rapid manner. This type of braking is reserved for situations where there is an immediate danger, such as when a pedestrian suddenly steps onto the road or a vehicle unexpectedly stops in front of you. Emergency braking is characterized by a sudden and intense deceleration, which can result in a shorter stopping distance than normal braking. However, it should only be used when absolutely necessary, as it can lead to loss of control or skidding if not performed correctly or if road conditions are unfavorable. It's important for drivers to understand the distinction between normal and emergency braking and to use them appropriately based on the specific circumstances they encounter on the road. Normal braking is for routine slowing down and stopping, while emergency braking is a last resort measure to prevent accidents in critical situations. To calculate the emergency braking distance, you divide the normal braking distance by 2. It is important to maintain a safe following distances to prevent collisions, as this increases the risks of tailgating and hard braking. It's also important to note how distance should increase with higher speeds. It is important to keep minimum distance to the front. Too little distance is not only dangerous, but also punishable by law. Outside the built-up areas, the 2-second distance applies. When driving outside built-up areas, it's crucial to maintain a minimum following distance of at least 2 seconds behind the vehicle in front of you. This distance allows for a safer reaction time in case of sudden stops or unexpected events on the road. Adhering to the 2-second rule is a fundamental practice for ensuring road safety and preventing rear-end collisions while driving in less densely populated areas. Drivers can easily determine the 2-second following distance by selecting a stationary object or marker on the road, such as a sign or a tree. Once the vehicle ahead passes that marker, they should start counting the seconds it takes for their own vehicle to reach the same point. If it's less than 2 seconds, they should increase their following distance to ensure they have adequate space to react to any potential hazards. This simple method helps drivers maintain a safe gap between vehicles and minimize the risk of accidents on the road. It's crucial to recognize that our physical condition, experience level, and emotional state all play pivotal roles in determining how we behave on the road. Physical condition, first and foremost, our physical condition can greatly affect our driving. For instance, when we're feeling unwell, have a headache, or are dealing with physical impairments, our ability to drive safely may be compromised. In such situations, we tend to drive differently than when we are in top shape and fully focused on the road. Experience matters. Experience plays a vital role in how we approach driving. If you've recently obtained your driver's license, you're likely to drive differently than someone with several years of driving experience. This is because the more often we encounter various driving situations, the more confident we become in dealing with them. Experience enables us to better assess potential consequences and make safer driving choices. Confidence and experience. It's worth noting that confidence tends to grow with experience. As we become more familiar with the complexities of the road and different driving scenarios, we develop a heightened level of confidence in our abilities. This increased confidence can influence the speed choices we make while driving. Emotions and attitude. Additionally, our emotions and attitude toward ourselves, other road users, and the traffic system can significantly impact our choice of driving speed. For example, feeling stressed, angry, or impatient can lead to riskier driving behaviors, such as speeding or tailgating. Conversely, A calm and positive attitude can promote safer and more responsible driving. In adverse weather conditions such as rain, fog, or snow, it's essential to adjust your driving behavior to ensure safety on the road. Here are some key points to remember. Drive 50 kilometers to visibility less than 50 meters. When visibility is reduced to less than 50 meters due to weather conditions, like rain, fog, or snowfall, it's crucial to reduce your speed to 50 kilometers per hour or lower. This allows you more time to react to unexpected situations, ensuring safety. Be cautious of sudden fog near water bodies. Keep in mind that areas near water bodies, such as rivers and lakes, can experience sudden and dense fog. Stay alert and be prepared for rapidly changing visibility in such areas. Use headlights and maintain a safe distance to improve your visibility and make sure other drivers can see your vehicle. Always turn on your headlights in adverse weather conditions. Additionally, maintain a safe distance from the vehicle in front of you. This provides you with enough reaction time to avoid accidents. Avoid driving in the center of the lane. It's wise to avoid driving in the center of the lane during adverse weather conditions. This is because oil or other hazardous substances on the road can accumulate there, making it slippery and dangerous. Staying slightly to the side of the lane can help you maintain better control of your vehicle. By following these guidelines, you can reduce the risks associated with low visibility conditions caused by rain, fog, or snow, and contribute to safer road travel for yourself and others. Drive safely, and always prioritize safety when weather conditions are less than ideal. It is important to consider the challenges of driving in areas with limited visibility, such as wooded areas, hills, and curves. It is important to note how weather conditions impact road conditions, including dry, wet, icy, or snow-covered roads. Crosswinds are another factor to consider. It is important to consider factors affecting visibility, such as daylight, window cleanliness, and glare. The guideline stresses the importance of driving within your range of vision and being able to stop within the range of low-beam headlights, particularly on narrow roads. There are difficulties caused by rapidly changing light conditions. Therefore, it is emphasized on the increasing of your safety distance and using the red edge of the road as a reference point when visibility is poor. In rural areas, it is advised that the drivers to anticipate slow agricultural vehicles and highlights challenges like narrow and dirty roads. It is important to maintain a safe following distance and waiting for suitable overtaking opportunities. We recommend you read the following book to ensure success in driving license test in Germany. Book name: Pass Your German Driving Theory Test, German Safe Driving Comprehensive Study Guide with key educational materials and 700 plus questions. You can obtain the book from Amazon at the following link.